Audible or not? नहीं था क्या audible? Okay. Hello dear friends, welcome once again. I would like to have the concurrence regarding the quality of video as well as audio once again. So tell me whether the audio is properly transmitted from my side. Probably I don't have problem now because the problem which we had earlier is been resolved. Yes, now it's clear. Anyways, the agenda behind today's video had been very clear and precise. We have been discussing about the Nyquist plot. And one of the important information I would like to communicate to all of you, probably for the next 4 days, I may not have the classes on our GATE Academy Global because of certain medical emergency. So probably till Monday we won't have any class, and from Tuesday onwards again we would be having the same timing, precisely at 3 p.m. we would get live, and around 1 hour we are going to spend together. I repeat, for the next 4 days, including tomorrow, day after tomorrow, and probably Sunday and Monday, we may not have the classes because of certain medical emergency. And from there onwards, from the Tuesday onwards, we would have the class. Agreed? Agreed, no? So nobody should get confused, sir, why the thumbnail is not being created, why the classes are not being held. No, you did not to have any second thought. From the Tuesday onwards, definitely we would resume our control system once again. Anyways, keeping aside each and everything, let me go ahead with the Nyquist plot. Let me briefly discuss few of the important points which had been consisting of the Nyquist plot, and then we would take few of the transfer function, we would draw its Nyquist plot, and we would also try to analyze how the stability can be analyzed using the concept of the Nyquist plot. The first important point comes over here, like the concept of the Nyquist plot. Just a minute. The concept of the Nyquist plot is being taken forward from the concept of the polar plot, or you can say the Nyquist plot is being the extended form of polar plot. So what I would say, until and unless you do not have the fair idea about polar plot, probably you would not be able to smash the problem related to the Nyquist plot, polar plot. Many of the times I have seen the student used to have doubt, so the given graph or the given plot had been a polar plot or whether it had been a Nyquist plot. My dear friend, if that plot is being a unclosed path, in that case it's gonna be the polar plot, which starts from omega is equals to 0 plus to infinity plus. And similarly, if that plot or the path has been a closed contour or closed struct, in that case it becomes a Nyquist plot. So what I am saying over here, many of the times the student do have certain doubt, sir, in this problem I did not able to understand the problem had been a polar plot or whether it had been a Nyquist plot. You need not to have any second thought. If it has been a complete closed path, by default it becomes a Nyquist plot, otherwise it's been the polar plot. So here it had been a closed path or closed contour. It had been. Why it's been the closed contour? Because the omega, it starts from 0 plus, goes to infinity plus, comes to infinity minus, goes to 0 minus, and goes to 0 plus once again. So that means you have been starting from omega is equals to a very small positive value and comes back to the same value, and that has been omega is equals to 0 plus. But in case of polar plot, we start from omega is equals to 0 plus and we land up ourselves till infinity plus. That is why it has not been the closed contour. In the same sequence, let me go forward, and we would be talking about the need of the Nyquist plot which had not been satisfied or which had not been fulfilled by the polar plot, and that has been stability. Stability analysis can be made using Nyquist plot with the help of principle of augment. That is why the Nyquist plot is more prevalent plot while doing the analysis of the stability of the system. But still, little bit idea about the gain margin or the phase margin can also be inferred using the polar plot. But still what I am saying, if you really wants to dive into the stability criteria of the system, you had to have a Nyquist plot that had been the extensor of the polar plot, and once you have that, definitely with the help of principle of augment, you can find the stability of the system. In the same sequence, let me move forward. What is going to be the next point over here? The principle of argument. Principle of argument is the key point through which the stability of the system would be assessed. Stability of the system would be assessed. Stability of the system would be assessed. In the same sequence, let me move forward, and in the next slide, let me briefly discuss about the principle of argument. What the principle of argument does? Actually, the principle of argument is nothing but the mapping between the S-plane as well as GSHS plane. Could you understand what I am saying? It's been the mapping between S-plane as well as GSHS plane. If you had a certain closed path over the S-plane, how it gets represented over the GSHS plane, that methodology or that mapping methodology is being discussed by the principle of argument. So what we have been doing over here, let's take you had a complex S-plane, real axis it had been, and similarly imaginary axis it had been, and similarly towards right hand side we had the GSHS plane. Again it had been the real axis of the GSHS, and similarly it had been the imaginary axis of the GSHS. So what I am saying, it had been S plane, and GSHS is going to be the function of S. Yes, no? GSHS is going to be the function of S. You can write function of S, or simply you can write GSHS. And GSHS is going to be a complex variable. Let's take its real part. You can call it U. This has been the U axis, and similarly it had been the imaginary variable of the GSHS, and let's take it's a B axis. It's a V axis. So what the principle of argument says? The principle of argument says, if you had a closed path, a closed contour, let's take you had a closed path, a closed contour in S plane. I repeat, if you had a closed contour in S plane, let's take in S plane you had a certain transfer function where one pole, 1 0 we had. One pole and 1 0 we had, and now this closed contour is encircling the closed pole. So what I am saying, the encirclement had been taken place. Let's take it's been the pole now, and let's take it had been the 0 now. It had been 0 now. So may you know the encirclement of the pole or 0 had been taken place, only pole had been taken place, or only 0 had been taken place. Obviously, if we'll talk about this closed contour, you may call it this closed contour as C1. The enclosement of the pole had been taken place, and if it happens so, if we'll try to map, what I'm saying, if we'll try to map the each and individual point of this closed contour over the GSHS plane, we will get to know, again it should be a closed contour, obviously nobody should disagree on it. What I am saying, if all of the point had been mapped over the GSHS plane, so obviously as this complete point was making a complete encirclement or enclosed encirclement, there would be the enclosed encirclement. But one of the important conclusion has been deduced by the principle of argument, and which we are going to use for the further investigation of the stability. As per the principle of argument, it states, if there had been P and Z number of poles and zeros encircled over the S plane. So may you know what had been the P over there? The P is number of encirclement of poles, and similarly what had been the Z over there? The number of encirclement of zeros, number of the encirclement of zeros. And as per the principle of argument, the N used to be number of encirclement of origin on S plane. Could you understand what I am saying exactly over here? Should I repeat once again? So what I'm saying here, the concept of the mapping is being used. I know many of the students find the Nyquist plot a little bit difficult because they do not know much about the complex variable. That is the first thing, and even they are not much aware with the concept of mapping. That is the second thing. What I'm saying, we had the two different planes over here. This has been the S plane. Obviously, its real part is gonna be, or the real axis is gonna be the sigma axis, and similarly, its imaginary axis is gonna be j omega axis. And now in future, you may have the different kinds of the open loop transfer function. Like you may have s plus 1 divided by s plus 2, you may have s divided by s plus 1, s plus 2. Now what would happen? Now if you'll replace s with j omega, just try to understand what exactly I wanted to communicate over here. If you want to keep s as j omega, what would happen? There would be a certain real part, and similarly there would be a certain imaginary part. Real part would be the function of what? Omega, and similarly imaginary part would also be the function of omega, or put together I can say it would be a real variable as well as imaginary variable. As we have studied in case of mathematics, we used to call that complex variable as w, which we also call it as a function of f and z. And may I know how this function would look like? It would have the real part as well as imaginary part, but the real part and imaginary part is not gonna be number, it's gonna be the function. It's gonna be the function. Could you understand what I'm saying? Now what we have been doing over here, we have taken a closed contour. Randomly I have taken a closed contour over the S plane, and now when the closed contour had been taken place, so what would happen? Just try to understand in this way. Let's take, we had a GSHS which is equals to of 1 divided by of s plus 1, s plus 1. Now the different values of s has to be fed in. The different values of s has to fed in. So what would happen? Continuously this point had been dislocating from its point. So obviously because of s has been dislocating from its point, the new worth of u and v which is supposed to come after feeding the value of s over here, they would also be continuously dislocating from its point. So what I'm saying, if here it had been a closed loop, there also it would be a closed loop. I can say there had been the mapping between s plane to GSHS plane. GSHS plane. Could you really understood what exactly we have been talking about? So if the point P1, this has been the point P1, definitely would get mapped over the GSHS. Similarly, point P2 would get mapped over the GSHS. And once again, if you're taking all of the continuous point, if you come back to the P1, again, this would be completing its one round. So one thing has been quite sure. Sir, may I know what it has been? The quite sure part had been, if there had been the encirclement, there would also be the encirclement. If there it had been a closed loop, there would also be a closed loop. There would also be a closed loop. If you want, I can show you few of the important conclusion, but I think that is not the criteria, at least over the concept to the question. One of the important outcome had been deduced from the principle of argument. We are going to discuss that part in this particular point. See what we have been talking over here. The P, what had been the P? The P is nothing but the number of poles which was encircled over the S plane. Similarly, Z, what had been the Z over there? The number of zeros which were encircled over the S plane indicates how many times the origin at the GSHS plane is going to get encircled. Like if Z is being deficient over the P, let's take the Z had been 2 and the P had been 3. In that case, 3 minus 2, it's simply going to be 1. In that case, the origin of the GSHS plane is going to get encircled once. Similarly, if I take, there had not been any 0 at all, and the 2 number of poles we had, in that case, the 2 is going to get subtracted with 0. End of the day, the number of n is which we are going to get, it's going to be 2. What does that mean of it? That means the encirclement of the origin is going to take place twice. Takes place twice. Here, the one of the important conclusion which we would like to write over here, it's been, if n is positive, encirclement would be presumed anticlockwise, and similarly if n is negative, encirclement would be presumed as clockwise. दीपक गुप्ता, हेलो सर, हिंदी में नहीं होगा क्या कंट्रोल सिस्टम? Deepak, I would like to say one thing, at least on our GATE Academy Global, our mode of communication has been completely in English. So at least you cannot expect the mode of communication or language which we would be using over this channel to be Hindi, but definitely we would have something on our main channel where we used to have the multilingual, or I can say the Hindi and English, the amalgamation of both in our main channel. Agreed? So may I know how many times the encirclement had been made or would be made over the GSHS plane? Once you will start feeding the data, the pole had been encircled once and 0 has not been encircled. So the deficiency between P and Z had been plus of 1. The 1 indicates the one time encirclement, and similarly plus sign indicates yes, there would be the encirclement in the clockwise direction, into the clockwise direction, like this, like this. In the same sequence, I think it's the right time to move forward, and we would take few more number of situations. Again, we had a S plane. The point from the S plane has been mapped over the GSHS plane. GSHS plane. Let me copy this down and bring it towards downside. Bring it towards downside. Like this it had been. This has been the S plane. This has been the S plane. The sigma axis, j omega axis, or I can say real axis, imaginary axis, real axis, imaginary axis. Let's take, again we have taken a random closed loop path, and now it had been encircling 2 number of pole and it could not encircle the 0 at all. That means we had a transfer function, the 2 number of poles we had, 1 number of 0 we had, but the way the encirclement had taken place, it has been encircled only and only 2 number of poles. So may I know how many times the encirclement of the origin of the GSHS would be taken place? And that would be exactly 2 times. Would it be anti-clockwise or would it be clockwise? Obviously sir, it would be anti-clockwise. How did I know about it? We have just used the formula. The formula had been the encirclement of the origin over the GSHS plane is being defined as n is equals to a p minus of z. What had been the p over there? The p is nothing but the number of encirclement of the poles. How many number of poles had got encircled? 2. How many number of zeros got encircled? Only 0. So obviously the answer is simply going to be 2. So as far as this complete structure is being concerned, it would look something like this. Now I have seen many of the times students used to have doubts on how many times the encirclement has taken place. You can use a simplest form. You start from the origin and take one straight line outside. How many times the intersection had been taken place? 2 times the intersection had been taken place. So just count encirclement of the origin as 2. That's the first thing. And similarly, the direction do also make sense. May I know where in which direction? It would be, obviously it has to be in anti-clockwise direction. All the way it has to go in this path. All the way it has to go in this path. So I have seen many of the times in problem, until and unless you are not able to find the number of encirclement, you may not be able to crack this problem out. So if you are looking for the number of encirclement of the origin, you do one thing, you bring a straight line outside from that point. How many times the intersection over the Nyquist plot had been taken place or the closed loop path has been taken place, that would be the value of n. Now, the direction, had it been clockwise or had it been in anti-clockwise, that is going to decide whether the value would be positive or negative. Here it had been clearly known the value is going to be positive. I know many of the students may also be thinking, sir, why don't we take that straight line from this point? In that case, we would not be able to know how many number of times the enclosement had been down, encirclement had taken place. So what I am saying, forget about this point. Forget about this point, except this point. If you bring any of the ray outside from this origin, no, at least the result would be very same. 2 times intersection had been taken place and hence the worth is being 2. And similarly, as it has been anti-clockwise, obviously it's going to be plus of 2. It's going to be plus of 2. Agreed? In the same sequence, let me take another scenario. We had a system, we had a system GSHS. Maybe it might be having 3 number of poles and similarly 3 number of zeros. So let me place where they have been. Let's take the 3 number of poles we had and similarly 2 number of zeros we had. And let's take the zeros had been in the form of complex conjugate. 2 number of zeros we had. And we have selected a closed contour in such it had been enclosing or it had been encircling. It had been encircling 2 zeros as well as 1 pole. Sort of this. Agreed? Now, what had been happening over here? The same formula we are going to use over here. The number of encirclement over the GSHS plane is equals to of p minus z, where the p had been, how many p? P means it's not the total accountability or the total count of the pole. This has been the number of pole which has been enclosed by this closed contour. It had been only 1. Going to get subtracted with 2, the result is being simply minus of 1. Simply be minus of 1. 1 indicates, or the magnitude as a 1 indicates there would be the encirclement of the origin over the GS-HS plane once, and the minus sign indicates the encirclement would be clockwise in direction. So randomly it would be sort of this. Randomly it would be sort of this. Many of the students would think, sir, what had been the basis behind it? If you want, we can give the little bit derivation part of the principle of augment. Just understand in this way. See what it's been happening. As you would be dislocating from your point, definitely what would happen? As the S is changing, GSHS would change its worth, and as continuously the point is being changing its location, what would happen? The worth of GSHS would also change. And once the path had been enclosed, even here also the path would get enclosed. Path would get enclosed. Now many of the students may also ask, sir, till this point it looks okay, but what had been the advantage and how we can exploit this complete concept over the concept of the stability which we have studied earlier. What I am saying, we can use the principle of augment for the finding the stability of the closed loop system. For finding the stability of the closed loop system. May you know what would be that approach? See, we'll try to understand what we have been doing over here. This has been the S-plane. Try to understand what exactly we have been discussing over here, because this has been the important point where many of the students are not able to digest the concept very well, and in future they would say the Nyquist had been the difficult most part of the control system. What I am saying, so far I was taking any of the random closed loop over the S-plane, any of the random closed loop over the S-plane, and from the principle of augment, one thing I had been quite sure, the number of encirclement of P and Z is going to decide how many times the encirclement of the origin over the GSHS plane would take place and in which direction it would take place. The formula was P minus of Z. P minus of Z. What I am going to do now we are playing smartly. Now we are playing smartly. What I am going to do, we are going to encircle all of the poles and zeros which were there towards the right hand side of the S-plane. Now many of the students would think, sir, what is the need of it? My dear friend, there had been the need, and that's nothing but the stability. In case of a stable system, all of the closed loop poles has to be towards the left hand side of the S-plane. If either of the closed loop pole goes towards right hand side of the S-plane, that's done, the system becomes an unstable system. System becomes an unstable system. So what the Nyquist has done, Nyquist has played smartly. What he did, try to understand. He took a path, just try to understand what I am saying. He took a path like this. Let's take he had taken this point as omega is equals to 0 plus, this point as omega is equals to of infinity plus, and now what he had been doing, from infinity plus to infinity minus, he had taken a semicircle with the radius is equals to infinity. Semicircle with the radius is equals to infinity. What's the benefit the person is getting? The benefit of the person is been getting that if you had a semicircle which had been oriented towards right hand side, and if its radius is been infinity, what's going to happen? It is going to encircle all of the component towards right hand side of the S-plane. Towards the right hand side of the S-plane. Yes. Not only that, again the Nyquist had come back to the value omega is equals to minus infinity. From minus infinity we go to the 0 minus, and from 0 minus we go to the 0 plus. So total 4 number of segment we had over the Nyquist plot. May you know what are the Nyquist plot segment we had? From 0 plus to infinity plus, that had been the segment number 1. That had been the segment number 1. From infinity plus to infinity minus, that had been the segment number 2. Similarly, from infinity minus to 0 minus, that had been segment number 3, and similarly from 0 minus to 0 plus, that's going to be the segment number 4. So as far as the Nyquist plot is being concerned, total 4 number of segment we are going to have. The first is going to be 0 to infinity, obviously in plus sense, infinity plus to infinity minus to 0 minus, and similarly here it goes 0 minus to 0 plus, 0 minus to 0 plus. Agreed now? Now many of the students used to start thinking, sir, what are their segment and when they would be used? Most of the time, what I am saying, most of the time the segment number 2 is not going to used. segment number 2 is most of the time is not going to used. May I know when the segment number 2 would be used? The segment number 2 is going to use only and only when you have an improper transfer function. What I am saying, when you have an improper transfer function, or I would say the number of, I repeat, the number of zeros are greater than the number of poles. But in most of the open loop transfer function in which you would be doing the analysis, there would be a proper transfer function where the number of poles would be greater than the number of zeros. Number of poles would be greater than number of zeros. Could you understand? If you don't understand, let me show you. Let me show you. See, S, let's take you had GSHS is equals to S. GSHS is equals to S. Yes. If you had this, may I know whether this GSHS is been a proper transfer function or improper transfer function? Everybody would say, sir, it had been an improper transfer function. Improper transfer function. And one of the best thing regarding the S is been, let's take the omega is brought to the infinity plus and omega has been brought to the infinity minus. If the omega has been brought to the infinity plus, its magnitude, no, magnitude is obviously infinity. And if we'll talk about its angle offered by this system S is going to be tan inverse of plus of infinity. So obviously the phase part is going to be plus of 90. And similarly, if we'll talk about the magnitude, if you feed plus infinity or minus infinity, magnitude would not change, it would remain plus of infinity, but the phase would become minus of 90. Could you understand what I am saying? That means as far as the draw of S is being concerned, for a very large value of omega, when the omega is being very large plus infinity, had been landing towards somewhere else, and similarly it's been minus infinity, had been landing somewhere else. Could you understand what I am saying? So one thing has been quite sure, this segment number 2 would come into the picture only and only if you had a, I repeat, if you had a improper transfer function. If you had a proper transfer function, forget about each and everything, you are not going to face any sort of problem. Yes, in the same sequence, let me focus over the third. Anyways, third and first had been interconnected to each other. The first segment of the Nyquist plot is already been drawn earlier, and that is nothing but the polar plot. Because in polar plot we have seen the value of omega goes from 0 plus to infinity plus. Yes. And the third segment used to be invert of polar plot. Invert of polar plot. Yes. In the same sequence, I think it is right time to discuss a bit about the fourth segment. See, the concept of the fourth segment would come into the picture only and only if the type of OLTF is being greater than 0. So you will see many other times when the system is a proper transfer function, the segment 2 would not be present. And similarly, if you do not have any of the loose pole over the origin, again the second segment would not be there. So you would be dealing with the first as well as third segment alone. Could you understand what I am saying? First as well as third segment alone. Yes. Type 0. Now just try to understand in this way. If you have a factor like 1 upon s, because of 1 upon s, when you would be feeding, just try to understand what exactly we have been talking over here. When you feed omega is equals to 0, one thing has been quite sure, its magnitude is going to be infinity. So the magnitude part is pretty clear. The magnitude would go to the infinity, whether we have been keeping it 0, maybe a positive in sense or negative in sense. But try to understand. If we talk about its angle, 1 upon s could have been written as 1 upon j omega. If the omega is being replaced with a 0 plus, it would become j infinity with the plus sign. And in that case, the angle which would be offered by this is simply going to be plus of 90, whereas it becomes plus of minus 90. So obviously now it had been the two different places when we took the reference of omega is equals to 0 plus as well as 0 minus. See, if you had the transfer function like 1 upon s plus 1, No. 0 plus and 0 minus is not going to make any substantial difference. If you keep 0 plus, then also it becomes 1, and similarly the angle which would be offered by the system, it's been a pure real, so obviously the angle offered by the system would be simply 0. And if you'll feed omega is equal to 0 minus, then also you would be having the same gain as well as same phase. Could you really understood what I am saying over here? Could you really understood what we have been saying over here? Yes sir, we can. Now overall we can say very well, we wanted to cover all of the poles as well as zeros which had been kept towards right hand side of the S plane, and we did it with the help of a semicircle whose radius had been infinity. Either you talk about this radius had been infinity, and even if the fourth segment do exist, then also this radius is going to be infinity. Yes, no? 1 upon s, when you will feed the value of omega is equals to 0, the worth of this is simply going to be infinity. Worth of this is simply going to be infinity. If you guys are having any sort of doubt, no, you can raise over there. Because I know the Nyquist had been the nightmare for the many of the students. If you guys are having any sort of doubt, you can ask over the live chat. Definitely, I would try to deal those doubts if you guys are having. And I would repeat once again the information which had been communicated at very starting. Probably for the next 4 days, I may not have the classes because of certain medical emergency. From Tuesday onwards, we would begin our class once again, and obviously the timing would remain very same, in between 3 to 4 p.m. Tell me. No doubt. Okay, let me move forward. So now I have been selecting few number of open loop transfer function, and with the help of those open loop transfer function, I would like to draw its Nyquist plot. So here goes the first question, and that had been GSHS. Yes, GSHS. Let's take the GSHS is being 1 divided by of s plus 1. 1 divided by of s plus 1. Forget about anything. Focus over the section 2 as well as section 4. Will you have the section 2 as well as section 4 in this problem, or you won't have both? So let me start with solution. Its solution. The type of the system is being 0. That means at omega is equals to 0 plus as well as 0 minus, you would not be having the two different or two distinct point. Both would be the same point, or I can say, as it has been type 0 system, this segment number 4 would not be there. Segment number 4 would be absent. Segment number 4 is going to be absent. Similarly, if we'll talk about the segment number 2, will the segment number 2 would prevail over here? No, so segment number 2 is again not going to come into the picture. Why so? Because it had been a proper form of the transfer function where the number of poles were greater than the number of zeros. So obviously the segment 2 would also be absent. Now what we are going to do over here, we are going to have the polar graph paper on which first we would draw the polar plot and then the extension of the polar plot, and that's going to be Nyquist plot. This has been the S plane. Here it goes sigma, and similarly here it goes j omega. Yes. 1 upon s plus 1, how the polar plot would look like, we have already seen. At omega is equals to 0, the s would become 0, the magnitude would be plus, and that to real. What does that mean of it? That means it would be lying over the 0 degree line with the magnitude of 1. And as the omega increases, we had only and only factor of omega towards downside, magnitude would decrease, and as we had the factor of 1 upon s plus 1, because of that you would have the introduction of the phase which would be equals to of minus of tan inverse omega. As the value of omega would be keep increasing, angle would be more and more lagging, and at omega tends to infinity, it would simply be 0. So what I am saying over here, this has been like this. Sir, what happens if it has two different values? Then there would be the encirclement of 2n plus 1 into of 180 degree. That part we would be discussing, taking few number of questions. So probably this is not the point to worry much, at least at this moment of point. May I know what it had been? Obviously, sir, it had been the polar plot, and in future we can draw the Nyquist out of this polar plot. This has been the starting point of the polar plot, where the value of omega had been 0 towards positive side, and this had been here, it had been infinity plus. Now you have to draw the invert of this. Forget about the segment number 2, forget about the segment number 4. Once you will draw, the invert of this is being like this. And here even we had omega is equals to of infinity minus. So you can say the segment number 2 is overlapped at this point. All the way infinity minus was keep increasing when till omega is equals to of 0 minus, and you can see the segment number 4 had been compressed at this point itself, Agreed, no? Is being compressed at this point itself, and this has been the complete Nyquist plot for 1 divided by of s plus 1. May you know what would be its maximum magnitude? The maximum magnitude is simply going to be this length when the value of omega was minimal, which was 0. Obviously, this length had been 1. So this has been the Nyquist plot for the given OLTF, and that had been 1 divided by of s plus 1. Could you agree on it? Obviously, each one of us would be agreeing on it. Let me do one thing. Let me increase the number of poles in this system. Earlier it had been 1 divided by of s plus 1, had been changed to 1 divided by of s plus 1 getting multiplied with s plus 2. This has been the next problem. Again, the same methodology has to be followed. Focus over the existence of the segment number 4 as well as segment number 2. Both would not be present. Why the segment number 4 would not be present? Because it had been a type 0 system. And as it has been a type 0 system, the 0 plus as well as 0 plus would be located at the same point. So forget about that. And similarly, even the segment number 2 would not be there. So what we would be doing over here, let me draw the S plane once again. Yes. How this would look like? At omega is equals to 0, the S is going to be 0, and once the S becomes 0, the factor which had been left out is been 1 upon 2, which is been pure real as well as positive, and hence the angle which would be provided by the system at omega is equals to 0 is going to be 0 degree with the magnitude of half. So what we are going to do? We are going to have the reference of 0 degree line, and I would go radially half distance away from the origin. So you are going to have a circle, intersection of the circle with the radius of half as well as 0 degree would make the location of half comma 0. And as the omega is been increasing now, what has been happening? The magnitude would be keep decreasing, and end of the day, it has been like this. Okay, so I would request from each one of you, complete this. So I would like to have the request from each one of you. Complete this Nyquist curve. So again the same thing takes place. The starting point had been omega is equals to of 0 plus, and it had been omega is equals to of infinity plus. This has been the first segment of the Nyquist plot, and which is also called the polar plot. And once you will take its inversion, you will find it is making certain sort of heart, And when you would make a certain sort of art, you yourself would be able to analyze that the infinity plus as well as infinity minus, 0 plus as well as 0 minus has been finding its location at the very same point. It's been at a very same point. So what we have been happening over here, so it had been like this. It had been a heart shape. It had been a heart shape. Could you understand what I'm saying? Could you understand what I'm saying? Now, many of the students would also think, sir, how the stability can be assessed with the help of Nyquist plot. The stability can be easily assessed. The same formula we are going to use over here. The n is equals to of p minus of z. N is equals to of p minus of z. See, so far as per the concept of the principle of argument, the n had been the number of encirclement of the g j omega, h j omega or GSHS plane. Yes. But what had been happening over here, but now had been n to be the encirclement of minus 1 plus j0. Now, many of the students would think, sir, why the change had been taken place? Why you have changed your stance? My dear friend, you had been allocated with the GSHS and you have been looking for the stability of the closed loop system, and that can be easily calculated when 1 plus GSHS is being taken in account. We got its characteristic equation and we have located whether its closed loop pole have went into the right hand side or not. If neither of the pole had gone into right hand side, the system remained a stable system. Could you understand what I am saying? What I am saying, so far you were drawing the Nyquist plot. You were drawing the Nyquist plot for the GSHS. But the stability of the closed loop system would be assessed not from the GSHS, from 1 plus GSHS. Now because of 1, what would happen? The complete Nyquist plot would be shifted with a unit of 1 towards right hand side. And now I would see the encirclement of origin. Now I would see the encirclement of the origin. So rather shifting the complete Nyquist plot, I could have taken the different methodology. Rather searching the enclosement of the origin without displacing the Nyquist plot from its place, why don't we search the encirclement of minus 1 itself? Yes, no, what I am saying? This was my origin. The complete Nyquist plot had been shifted towards right hand side by 1 unit. So rather doing so, what we can do, we can keep Nyquist plot there itself, and now we can see the encirclement of minus 1 plus j0. So what I am saying, many of the students used to have one doubt, sir. As per the principle of argument, we were talking about the encirclement of origin, but now we have been talking about the encirclement of minus 1 plus j0. Why this change had been taken place? This change has been taken place because we had been talking about the stability of the closed loop system, and the stability of the closed loop system would be calculated from the factor 1 plus. GSHS plot is already been there, 1 plus would be accounted, and there the encirclement would be minus 1 plus j0. Yes, 1 plus j0. Now, I am not going into the detailed analysis of it, but once you will take the characteristic polynomial, no, in characteristic polynomial, the P used to be the number of open loop poles, poles of what? Characteristic polynomial, number of open loop poles of characteristic polynomials towards right hand side, and that is nothing but very same as number of open loop poles towards right hand side, poles at right hand side, at RHS, at right hand side. Yes. And similarly, if we will talk about the zeros, what had been the zeros over there? The number of zeros, if we will be talking about the number of zeros of the characteristic polynomial towards the right hand side of the S plane. Once you will conclude and once you will have the one-to-one relationship, you will get to know the zeros of the characteristic polynomial is very same as the closed loop poles. The closed loop poles. So what I am saying, Z had been the closed loop poles towards right hand side of the S plane. Closed loop poles at the right hand side of the S plane. Closed loop poles at the right hand side of the S plane. Closed loop poles at the right hand side of the S plane. So for a closed loop stable system, for a closed loop stable system, for a closed loop stable system, what has to be there? You had to force the value of Z to be 0. I should not say what must be the value of n, but at least I must ensure the value of closed loop poles towards right hand side has to be 0, and that means you must ensure the value of z had been 0, and according to that you must ensure the value of n is always equals to of p. What does that mean of it? That means the number of encirclement of minus 1 plus j0 should always be equals to the number of poles towards right hand side of the S-plane. Which poles? Open loop poles. Which poles? Open loop poles. Could you understand what exactly we have been communicating over here? So till this point, each and everything must be clear to all of us. Let me focus over this point. We come back to this problem once again. 1 upon s plus 1 that had been open loop transfer function GSHS. We want to search whether it's been a stable system or not. Tell me whether it's been a stable system or not. We can do it manually, even we can do it with the help of Nyquist plot. In case of Nyquist plot, what we are going to do, we are going to have the, or we are going to calculate the number of the critical point. And what's going to be the critical point for the closed loop stability? Obviously minus 1. This has been minus 1. Minus 1 had not been encircled, at least in this Nyquist plot. So as far as the formula of n is equals to p minus of z is being concerned, in case of principal argument it's something different, but in case of closed loop stability where the n had been the number of encirclement of minus 1 plus g0, similarly p had been the number of open loop poles towards right hand side of the S-plane, and similarly z had been the number of open loop zeros towards right hand side of the characteristic polynomial, and that is nothing but same as closed loop poles. So what I am saying, at least in this problem the value of n had been 0. What had been p over there? The number of open loop poles towards right hand side. I had only and only one open loop pole, and that had been precisely kept at minus 1. Obviously no pole towards right hand side, and the value of z had been 0. What had been the z over there? The number of closed loop poles. The number of closed loop poles towards right hand side is being simply 0. The system is a utterly stable system. If you want to know how did I know about it, again I can take 1 plus GSHS. 1 plus GSHS is equals to 0. So here it becomes 1 plus 1 divided by s plus 1 is equals to 0. Once we'll shift the data, s has been minus 2. That means only one pole we had, and that pole had been towards the left hand side of the S-plane. The system had been a stable system. In the same sequence, I think it's the right time to focus over this hard shape. Again, we would talk about the enclosement of this critical point, which had been minus 1 plus j0. The formula which we are going to use is going to be n is equals to p minus z. The basis behind this formula is already been known to us. What had been the n over there? The n is going to be the encirclement of the critical point. At least in starting 2 problem, I did not have any encirclement so far. What had been the p over there? The p is going to be the number of open loop poles towards right hand side. I did not have any of the open loop poles towards right hand side. Either you take the reference of this had been at minus 1, either it's been this. So it's simply going to be 0. So number of closed loop poles towards right hand side, once you'll feed in this data, that had been z, and that's simply going to be 0. The system had been a stable system. If you don't agree, what you can do? You can find its characteristic equation. How the characteristic equation would be defined? It would be 1 plus of GSHS is equals to 0. And once you do so, this had been s square plus of 3 of s plus of 2 is equals to 0. S square plus of 3 of s plus of 2 is equals to 0. Plus of 2 is equals to 0. Yes. And obviously, if all of the data are being positive, there is no doubt all of the poles are being kept towards the left hand side of the S-plane, or I can say all of the pole had the negative real part. The system is being a stable system. System is being a stable system. I would like to have one more input. If rather having the numerator as 1, if it would have been k, and similarly k, if the k is being keep increasing in positive sense, the system would it become unstable for any precise value of k, or it would always be stable? I would like to have the input from each one of you. What I am saying, rather having the open loop transfer function as 1 upon s plus 1, we had the transfer function as k divided by s plus 1, and similarly here also k divided by s plus 1 into s plus 2. What I am saying, if the k is being keep increasing, the system would remain the stable system, or it would become an unstable system after certain value of k. See what I am saying, if the value of k is being keep increasing, no, what would happen? The angles are not going to change because the k remained a positive value as well as the real value. Only it is going to expand from its place. And as the expansion is being taken place, no, it would become something like this. It would become something like this. For the different values of k, it would become something like this. For the different value of k, it had been keep expanding. It had been keep expanding. But still one thing has been quite sure, -1 plus j0 has not come in danger at any cost. Still z had been 0. And if you take k over here, no, if you take k over here, so what I am saying, so here it had been s plus 1 plus k is equals to 0, s had been -1 plus k, and if the k had been made sure that it would be a positive real quantity, one thing has been quite sure, the closed loop pole is still towards the left hand side of the S plane. The system remained a stable system. Could you understand what I am saying? The same thing is going with this. If the k is being keep increasing, the shape of the heart would be keep increasing. If the shape of the heart is being keep increasing, what would happen? Like this it would be, like this it would be, like this it would be, like this it would be. But one thing is very sure, at omega is equals to infinity, it has to start from 0 all the way. At any cost, whatever the value of k you may feed, it would not be encircling at any cost. It would not be encircling at any cost. So that means one thing has been quite sure. If you feed even k over here, the k has to be positive, what I am saying. If the k is being fed negative, what would happen? Because of that negative k, even the phase would also get introduced, and this complete curve would get shifted from its place. So that is why only and only positive value of k had been permissible. May I know what would be the case in that case? Again, it had been 2 plus of k. And the same outcome we get out of it, it's been the k has been the positive value. Yes, it would be a stable system alone. So with the help of this concept which we have studied, probably in next class we would also be discussing about the gain margin and as well as phase margin, gain margin as well as the phase margin. But till then, bye bye, take care. And yes, the next thing which I would like to inform once again, probably for the next 3 to 4 days we may not have the class because of the medical emergency. We may not have the class. Agreed, no? So if you guys wants to have a little bit chit chat with me, the technical or non-technical, we can have it for the next 3 to 4 minutes. Otherwise, we would leave our session here itself. That is all. In that case, we would end our session here itself. Okay then, this is all about the today's session. We would meet with the next session probably after 5 days. Sir, is it advisable to practice ISRO previous year? No. First focus over the gate. Once you are done with that, probably you try to cover your all of the subjects from the gate syllabus itself. Because in 2 hours covering all of the 100 questions are not that easy. So the accuracy do make sense. Just focus over the width of the complete syllabus. Try to cover the complete syllabus, the complete topic. Is that part clear? So this has been the agenda behind the today's video. We would meet with the next video. Till then, bye bye. Take care.